Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 20th, 2025, just 2 days ago. This paper investigates a popular training method called reinforcement learning with verifiable rewards, or RL versus R. It finds that this method can actually make a model lose access to correct answers it previously knew. The paper is titled, "The Invisible Leash: Why RLVR May Not Escape Its Origin," and the implications for model training are quite significant. The authors argue that this technique acts more like a sharpener for existing knowledge than a tool for true discovery. Alright, to visualize this, the authors provide a really clear diagram. On the left, it shows the relationship between the base model's knowledge and the RLVR model's knowledge. The support here is basically the set of all correct answers a model can generate. So, we see preservation for answers both models know, expansion for new answers, and shrinkage for answers the trained model forgot. The pie charts on the right show this breakdown across different tasks, and the key takeaway is that the red slice, shrinkage, is consistently bigger than the green one, expansion. Okay, this table then details the specific numbers behind those pie charts, but for non-math reasoning benchmarks. We see the same categories: preservation, shrinkage, and expansion. And across different tests like Simple QA and SciBench, the story is consistent. The number of correct answers lost, shown in the shrinkage row, is consistently higher than the number of new answers gained in the expansion row. For example, on Simple QA, the model lost 13 correct answers but only gained 3. This really drives home the point that the training method is narrowing the model's overall knowledge. Moving on, these next graphs give us a different view of this same shrinkage phenomenon. We're looking at performance on 3 reasoning tasks. The vertical axis shows pass at k, which is the probability of finding a correct answer within k attempts. Notice how the green line, the trained ProRL model, often starts higher. This shows better precision on the first try. But as you allow for more attempts, the blue line for the base model often catches up and even surpasses it. This trade-off visually confirms that the training shrinks the overall pool of correct answers. This next table reinforces that idea by looking at entropy, which is a measure of randomness or diversity in the model's outputs. The key metric here is answer-level entropy, which measures the diversity of the final answers. And if you look at the last section of the table, for every single model pair, this number goes down significantly after training. For the DeepSeek 1.5b model, it drops from 2.15 to 1.24 on the AME benchmark. This is strong evidence that the model is converging on fewer distinct solutions, reducing its overall exploratory capability. So putting all these pieces together, we see a clear picture. While reinforcement learning with verifiable rewards makes models more precise, it comes at a significant cost. The model's pool of correct answers shrinks, and the diversity of its solutions drops. It essentially forgets more than it learns. The authors call this an invisible leash, a mechanism that sharpens existing skills but prevents the model from truly exploring new reasoning paths. They conclude that breaking this leash will require entirely new methods. That's all for this week's AI Research Roundup. I'm Alex, thanks for listening.